Hello friends, this is a video which shows the working of an RPM meter, and this RPM meter has been made with the help of a Atmega 32 IC, and this here is the sensor circuit. So as explained um, in the figure shown above, if you will refer to the circuit diagram, I have replicated the same circuit here. Okay, and my dev board gives a power supply of 5 volts. I'm powering my dev board through this programmer. It's a RoboKits programmer which I've brought here, and it's connected to my laptop over there. Okay, and so I'm powering this board from my USB port, and I have 2 pins which gives me power output. So one relimate goes here, and it is supplying plus 5 volts and ground to this sensor circuit here. Okay, and the other one here goes to the LCD. Okay, the LCD here, we can say it's not very clear, okay, but it's showing 2 readings: RPM, which is currently 0, and RPS, that's rotations per second, which is also 0. Okay, I'll quickly explain the sensor circuit. So this is plus 5 volts, this brown wire over here, it goes through a resistor, and this is the IR transmitter. So you see through the camera, there's a faint pinkish light which glows, so which cannot be seen with the normal human eye, but through a camera you can see it. Okay, so this is the 330 ohms connected here with this with the IR transmitter, and the black one over here, this is the IR receiver, and with this I have connected a resistor, a 22 kilo ohms resistor. Now I would prefer, I would propose that you use a potentiometer, because depending on light situations, this resistance has to be changed. But I have found a optimum value, and I have used 22 kilo ohms. It's working for me fine. It may not work for you, so you have to maybe play around with the value of this resistance a little bit. Okay, and so 5 volts here, also 5 volts here, and the resistance goes through 22 kilo ohms resistance, and it goes through the IR receiver, and it's connected to ground, and this ground is also connected to the circuit ground. So all the grounds are connected, which is very important. Okay, and from here, it's not very visible here, but if you will refer to the circuit diagram, you'll understand very well. I have taken an output from here, from the IR receiver, and the output goes to here. It goes to my INT0 pin of Atmega 32, that is external interrupt. Okay, so now apart from that, there's one more thing which I have done. I have connected an LED from here, okay, and there's a resistance obviously in series, and it is connected to a port, and this port is PA0. So what happens is that you see, I'll be measuring the speed of this motor. This is a motor of 60 RPM speed, and what I've done is that I've taken a white piece of tape. It's a 2-way tape which I've used here. So I've connected this white piece of tape on a small portion of the circumference, and the remaining is black. So when the black portion comes over this sensor, so the IR light goes up, and the majority is absorbed by the black part, right? Okay, so this will then the output which you will get from here, that will be the output will be high actually. Okay, and the output will be high because the resistance here will be high. So, and the moment a white part comes, the IR gets reflected and comes here. Okay, and what happens, the resistance drops. so you get a low output. So this is this change in voltage from a high to a low. On a black surface the output is high, and a white surface the output is low. This is called a falling edge, and this falling edge triggers and this output is connected to the external interrupt. So an interrupt will be generated every time a falling edge is observed. So every time this white portion over here, every time this white portion over here passes over the sensor, every time it passes over the sensor, what happens is that there's a falling edge, and every time there's a falling edge, an interrupt gets generated. So I know that this white part has passed over it. This has already been explained in the text above, and so now it is time that I show you how it works. So I'll connect this 9-volt battery to my motor, and you see whenever the white strip passes over the sensor, the LED will be toggled. So you see, whenever the white strip passes, the LED is getting toggled. The distance matters a little bit. And this is a 60 RPM motor, so the LCD screen will be showing 1 RPS and 60 RPM. So that's how the RPM meter works.